Right. So if you look at the question which is presented on screen there, what we need to do is to then look at what is the process involved when it comes to the drawing of such type of a center. So let's go ahead with the drawing. Right, so the first thing you do is to make sure that you draw a horizontal center line, because this is semicircular, so it's just a matter of drawing two lines like that. Once you have those two lines, the next thing will be to determine the span, and the span has been given as 1.8 meters, so that's 1800 divided by 10, which gives you 180. Then divide this by 2 so that you get the radius. So you then measure 90 millimeters. Right, so you then take your graduation and you measure 90, the compass, and you measure 90 millimeters. So that 90 millimeters is what we're going to be using for drawing. So I'm doing multiple runs simply because my compass is a bit small, and I also want it to be slightly darker. Right, so once you have this information, right, you know that this is going to be the span of the arch, right? So which means everything else which you're going to be drawing must fit inside here. So we are told that we are using 38 by 38 open legging. So if you're using 38 by 38 open legging, it means that you have to make a space for 38 by 38 open legging from this point going inside. So 38 divided by 10, that's 3.8. It's going to be approximately 4 millimeters. So what I'm going to do is I'm going to mark a point. I'm going to mark a point which is 4 millimeters away from this point, from the end here. So 4 millimeters away, I'll mark a point here. So once I mark a point there, then I can then draw another semicircular arch, but whose radius is 4 millimeters smaller than the first curve. Right, so once I get that, then I'm now in a position where I can then start to place the centers, right? So what I'm going to do with the centers is I'm going to subdivide this into a number of segments. Right, so I'm just going to take my 45-degree set square, then from the center you draw a construction line at 45 degrees. You also draw another construction line at 45 degrees. Make sure that these are not dark. Right, so once you have this information, we are going to bisect these once more, right? So to bisect these angles, I'm going to need to make use of my compass, and what I simply do is I open any random radius. Then once you open any random radius, you place your compass at the center. Then what you can do is you mark a point here, you mark another point there, another one there, another one there, and another one there. If you want, you can just draw a semicircle joining these all these points. So you can just draw a semicircle like this, it's fine. But if you want, you can just mark points at those points of interest, maintaining the same radius. Take your compass right to one of these points, you strike an arc there, you take your compass to the other point, you strike an arc again. Then you're going to notice that we've created a point here where those two arcs are intersecting. Then doing the same thing, an arc there, 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 then the final one here. Now once you have done that, you then line up those points, the center with those points which you have just established, right? Line up that in that, then you draw a construction line, the same thing here and there, you do the same thing. Here and that point, you do the same thing here, and the last point here, you do the same thing. Right, so maybe I can redo this one just to make it a little bit visible. So once you have this detail which you see on screen there, what I'm going to do is I am going to then draw from the center here. I'm going to draw or to measure a distance which is equivalent to the size of center, right? So the size of center is a 152 by 38 pine timber. So what does this mean? What we intend to draw there is let's say you've got a piece of timber, right? And this piece of timber is 152 and it is 38 wide. So what we are doing is we are taking these pieces of timber and we want to form an arch. We're going to cut this timber into smaller segments, which if joined together will form a continuous semicircle. So what's happening is we are going to be drawing an arch like this. Then on this arch we draw a straight line here and the straight line there. Then once you are done with this, what's going to happen is this piece will then be cut out. So at the end of the day you will have something like this. Then all this part is a cutout. So all that part is a cutout which is going to be taken away. Then you're just left with a portion like this. So the 152 part, this part still remains 152 millimeters. So we are cutting this from a section which is 152 millimeters thick, right? So that's the reason why you see that at this central center line we are going to measure 152. Then all we want to do is to form that profile. So 152 over 10, that's about 15. So 15 millimeters will be here, that point. Then what we're going to do is we're going to draw a line like this. So that's the first line which we have drawn. Then if we then draw a line along this bisector and draw just this small piece, you can see that we are forming that shape which I sketched just a few minutes back. And you can see that we have already formed that shape. So if you take another piece like this and place it here, do you see that those pieces will be able to form a continuous semicircle? So that's the technique and that's the idea. So from here, measuring along this line here, we want to measure 15 millimeters there, right? And besides measuring 15 millimeters, you can use your 45-degree set square, then take it to the intersection between that point and that point. But at times you need to be a bit cautious, because at times because this moves up and down, at times it's a bit off center. All right, but let me just see if I measured on the right one. Yeah, I had measured using the outside one, which was incorrect. So in fact it's supposed to be measuring from there to that 15 millimeter mark. So the 15 millimeter mark is actually there. So if I then look at the 15 millimeter mark and that, you see that it's slightly off. But what I can do is I can join these two like this. So that's what I can do. Then all you need to do is to then draw another line like this. So once I'm done with that, then the next thing which I'm going to do is to draw a vertical line here. Right, and you're going to see that the last piece will be half of what you have in the middle here. So if you've got the first piece like this, which is forming that semicircle, that segment, then we've got another segment here, and we've got another segment here. So to create a continuous smooth flowing arch, all we need to do is perhaps look at placing this at 45 degrees once more, then drawing a line, then drawing a vertical line like this, and lastly It's just a matter of drawing this last part, and you can see that we now have those different segments. Right, now once we are done with this, we still need to draw another set of these segments, which is offset by 22.5 degrees. Right, so this is meant to ensure that we've got proper joints, right? And this thing will not, because if you look at this joint, if it's just joined end to end, and if you apply a load, it makes it very easy to have these two sections separated. So to prevent that from occurring, what we do is, you've got a segment like this, then you've got another segment like that. So to make sure that these two are rigidly connected to each other, what you do is you take another piece like this, but you put it on the inside, right, such that that piece is going to be on the inside, but this section is visible. Then it's going to continue on the inside like that, then like this, then like that. Right, then all that's being done now is just a matter of maybe nailing these together. Right, so this inner piece is being used to make sure that there is proper joining of these two ends. So to facilitate that connection, it also means that this piece must have the same shape as the two outer segments. So what it simply means is we are going to be drawing another set of segments, but this time around using these lines, right, as the ones which we use for measuring the 150s. So this time around I'm going to measure 15 millimeters from here, 10, 15. Right, 15 millimeters here. Right, so when I measure that 15 millimeters here, what I need to do now is I need to take my set square and align one of these big graduations with the line which I've measured there, because what you want to establish is to establish a line such that this line is perpendicular to that one. So what happens is you draw a line like this, then you draw hidden detail lines which terminates right at the center like that. Then you will notice that this line will then allow you to then form another segment. So you now have another segment there. So what do we do here? What we do there is we then draw another hidden detail line for this section. So this is going to be hidden detail. So you now have the other segment here. Now once you are done with that segment, you go and do the same thing here. All right, then you do the same thing here, and lastly you do the same thing there. Right, so what do we do here? Go and measure another 15, right, and that 15 you will get it here, and all you do is you're joining that point and this point. Get it? Then once you do that, you can transfer this point here and you transfer it to that point, because they are going to be at the same level, that point and that point. Then all you do is you then join this point to the one which is right at the middle. Right, then once we are done with that, you can then measure another 15, which you can do by measuring that or by transferring that point to a point which is here. All right, so if you verify that, and that should give you about 15. Where am I measuring? Yeah, okay, thereabout. So all you need to do is this time around to join those two. Right, then from here you then know that you're going to be having a tie beam right at the bottom there. So a tie beam will be right there at the bottom. Now, to transfer loads from this arch right to the telescopic props, which I mentioned earlier on, what you are going to need to do there is to then place those props in the right positions. So you place those props at 45 degrees, so you use this line at 90, then the other 45 degrees. But these struts, which are being used to transfer loads from here, taking it to the tie beam there, they are made out of 114 by 38. So with this 114 by 38, you are going to spread that 114 on either side equally. So that 114 becomes 11.4, then you divide that by 2, 11.4 divided by 2, then it's going to give you about 5.7, which translates to 6 millimeters on either side. So 6 millimeters on either side means that I am marking a point here, and I'm also marking another point there. Right, so what this means is I'm going to just draw construction lines for now, but that detail will be going inside, and the same applies here. It's going to be going inside like this. So that's your first member here, but all of these members, right, should be such that they can be notched, right, to fit in to the profile formed by the tie beam and the central strut, which is there. So let's also place the tie beam there, it's 114, so it's going to be around 11, which you can either put as 11 or 12. It's still fine. So I'm going to put it as 11 there, and I'm going to draw a horizontal line like right. So that's the tie beam. It's been placed in its position. Let's now put the strut. So it's going to be 6 on this side, and it's going to be 6 on the other side. So drawing this would then be when you do the same thing here. Right. Then once we are done with that, so this detail can be done in such a way that you show some hidden detail, because this will go right inside to facilitate connection. This will go right inside. So once we have this detail, then you can then darken that part, which you can then finish off like that. Right, so you see that this part is going to be shaped like that. Then it also comes here, you cut it there, you cut it there, then this is the other straight side, so that it can fit in properly here. Then once you are done with that, you have to do the same thing for this other part. So we are now looking at 6 millimeters on either side, so that's 6 millimeters there, and this is 6 millimeters there. Then it ends there. Right, so you can see that we have managed to draw the center, but we're just left with a few things there. So we are told that the legging here is open legging, right? So open legging, that's the key word there. So because of that open legging, what we're going to do is we have to show that legging will be occupying this space, but you don't have to draw all the leggings because it will take you forever. Right, so what's the strategy with the leggings? So what you do is you measure 4 millimeter segments here, right? And you don't have to measure for everything. So for instance, let's see if we can measure 4 millimeter segments here. Right, so what we're going to do is we're going to measure 4 millimeter segments. So the first one is there, second one is there, the third one is there, the fourth one is there, the fifth one, sixth one, 7. You don't have to draw too many. Right, so once we are done with that, we then draw that. Then you, if you can, transfer a diameter 4mm line right here at the center. So a diameter 4mm, but it's very difficult to achieve, so I'll just do my best. So when you go to the next, make it tangent, and you draw a line here, then you move it above and you line up with the point which is here. Then you move it once again below the tangent, you line up with the point here, then you move it above, you line up with the point which is here. So that's how you draw the leggings. Then again you move it down, you line up with the point which is here, you move it up to line up the point which is there. So you don't have to draw for the entire circle, semicircle. So all you need to do is you then draw diagonal lines here. You skip one, then you move on to the next point, then you skip one, you move on to the next, skip one, you move on to the next point, like this. Then you change sides. This time around you are drawing that diagonal, then you move to the next, you do the same thing here, and you do the same thing here. Right, so this is now showing us that there is legging, but in between that legging there are gaps in between. But so if you want, if you'd like, maybe you should just darken so that it's will improve its visibility, and that's how you come up with the that well-defined shape. Right, so once you are done with this part, right, you are not done yet. You then have to start to draw what we refer to as the telescopic strut. What's a telescopic strut? So what is meant by this telescopic strut? It is just an adjustable prop or standard which is used for supporting centers. So it's like it's a dead shore. If you recall our lectures from building administration, so it looks like that. Then it has walls, right? Then this pipe runs into another pipe which has a bigger diameter, like this. And what happens on this pipe, we do have a slot, right? and this one continues like that, and it continues like that, and at some point we have a pin which joins this telescopic strut, the outer strut there. So there's a pin which joins these two. Then onto this telescopic strut we have square threads. So this thing is threaded, right? And what we do is we have a nut which runs on those square threads. So there's a nut here. So this is a nut, right? These are threads, right? Then this is the telescopic pipe. So this will then continue further down, right? This will then continue further down, and further down there's another segment, right? So this is just one continuous piece. So this time around right, then it then gets to a saw plate. Then below this saw plate, then you've got a sleeper, right? So you've got a sleeper. Then that's the basic arrangement which you end up having. It will be an arrangement like this, and the reason for having these two, one pipe which is smaller than the other, is so that we can extend or retract to suit whatever height which we want. And for rough adjustments, we just place these, we just adjust these by placing this pin into an appropriate hole. Then we just drive this thing in. So for fine adjustments, when you want to level your center, what you do is you make use of this square thread. So as you turn it up, right, you are extending, because that will then make sure that this pin moves up. But remember, this pin is also connected to the other telescopic shaft which we have there. So as a result, as you are turning this thing up, then it allows you to move this thing up for fine adjustments when you're doing leveling. Then when you turn it the other way around, then this nut is lowered, and as a result we are retracting that entire assembly. So this slipper is just meant to ensure that we spread load evenly, and we reduce pressure which is coming from the strut there. Right, so if you look at what we have now, the handout which I gave you is having these details, right? And I've explained how that telescopic strut works. And now we want to look at the specifications which are provided here, because it is those specifications which we are going to use in order to be able to draw the details which you see here the cross bearer, telescopic strut, the nut, the handle, square thread, pipe strut, and slipper. So because of limited time, I'll just demonstrate how to do that on one, but you guys will need to go and replicate the same details on the other two, right? So for instance, here we have to place a telescopic strut here. Then once you are done with that, you also need to put one there, one there. So for me, I will just do one, then you guys will do the rest. All right. So if you look at the details which we have on screen here, the telescopic strut, you use a diameter of 48. Then there was a mistake here on the pipe strut, it was also 48, but make it 75 millimeters. Then the cross bearer, it's going to be 228 by 38, slipper 228 by 38, handle and all that. So we're going to be following these specifications as we proceed. So you start by drawing the cross bearer, which is a piece of timber placed right at the top there, and we know that it's going to be 228 by 38 millimeters thick. So 38 millimeters thick will be drawn to scale and going to approximately 4 millimeters, right? So approximately 4 millimeters here. So what we're going to do is I'm going to draw a horizontal line there. Then what I can do is I can extend this vertical center line there. All right. Right. So once I've extended my vertical center line there, I know that this is going to be 228. So 228 divided by 10 is going to be 22.8, so approximately 11 on both sides. So if you want, you can make it 12, but I'm just going to make it 11 on both sides. Right. So with that, I'll be able to draw that line, and on the other mark here I'll draw another vertical line. So that's my cross bearer there. Right. So once you have that cross bearer, the next thing is going to be a cap plate. Right. So that cap plate is just a plate which is placed on top of this pipe strut. So it's a plate which is going to be placed there. If you can see here that there's a small piece of plate there, so you can make that about 100 and maybe 10 millimeter thick. Right, so if it is 10 millimeters thick, then it means we're going to measure a millimeter of thickness. So a millimeter of thickness will be somewhere there. So it's going to be at that level, but 100 will be 50 on both sides. So it's going to be 5 millimeters here and 5 millimeters on the other side. So what we do is then draw a line there, then draw a line there, right? So that is the pipe, that is the cap plate. Then from there we now want to draw the telescopic pipe, which we said is going to be diameter 48. So 48 is going to be approximately 50, so which means you need 2.5 millimeters on either side. So it's about 2.5 millimeters here and 2.5 millimeters on the other side. So you then draw a vertical line there and another vertical line here. Alright, so this is going to be representing the telescopic pipe. Then that telescopic pipe is going to be having holes, and those holes which go through will be at spacing of say 150 millimeters. So 150 millimeters divided by 10 is going to be 15 millimeters. So the first hole will be there, the second hole will be another 15 millimeters below. So you can draw, or you can show maybe the placement of 2, then we are good to go. So that's the first center there. Then from there 15 is here, so probably there. Right, so with this you can then use a circle stencil, and this pin is usually around 16 millimeters. So if it's a 16 millimeter pin, the hole should be around 18 millimeters, so you can make it 18 or 20. So if it's that size, then what simply means is you're going to use a diameter 2 millimeters or 3 millimeters, but 2 is too small, so I'm just going to use a 3 millimeter there, simply because it's difficult to use a stencil for that. But if you can use a stencil and draw these holes with a stencil, it's fine. You can also do that. Right, so we've got those holes in place. Now let's now look at putting the pipe strut in place. So that pipe strut in place, we will start somewhere there, but it's 75 millimeters wide, which you can approximate to 8 millimeters, so which means it's going to be around 4 millimeters on each side. 4 millimeters here, 4 millimeters on the other side. So like that, you draw a line there, you draw a line here. Right, so once you have this, you can then continue with other details. Right, so before I come back and fill in information about the nut, threads, and also the handle, I just want to draw the bottom part. So let me just say this is going to be the ground. Right, so if that is the ground, and I know that the slipper will have the same size as the cross bearer, all I need to do is to transfer this size, that width down to the ground. So I'm transferring this down to the ground there, and the thickness, we said it's going to be approximately 4 mils. So approximately 4 millimeters will be here. So we then draw that. Right, then all you do is just draw a small portion of the pipe strut. Then what you do is you then put a break. So this is how you put a break for a pipe or a shaft. Then on the opposite end, this one is going to be like this, and it comes and loops around. And because it's a pipe, we have to show the thickness. Right, so that's the break for the two. So what do we then do with that other stuff? So what we're going to do is we would like to put a nut, and that nut is going to be, of course, an M75, because the size of pipe which we used here is 75 millimeters. So here, instead of 60, use 75. Right, so what you simply do is you draw maybe 2 millimeters outside. You measure 2 millimeters from the outside surface here, and you measure 2 millimeters from the other side here. Then you just draw construction lines. Once you have those construction lines in place, you then draw bold horizontal lines, like what I'm doing here, and make sure that it is about 50 millimeters in thickness when it comes to the size of the nut. Right, so 50 millimeters divided by 10, that's about 5 mils. So 5 millimeters up to there. So all you do is then draw so once you have this, then you can darken this, but it mustn't go over the nut. Right, so you skip the portion where you have placed your nut, then you do the same thing on the other side. Right, so once you have this, you are in a position where you can then finalize the detail here. There. So once you have the nut in place, then the next thing which you will need to do is now the placement of threads, right? Or before you put your threads, you need to put the size of slot. So you're going to be having a slot here, and you're just going to make the slot tangent with these holes which you drew up there. So what we'll do is from there you draw a line there and a line below the nut, make it tangent with these holes, then you draw another line, you skip the nut, and you also draw another line, vertical line, which is below, right? So this is going to represent the slot, and by slot we are referring to that cut out, right, which allows the spin to move up and down. So you just close off that that slot. You close off that slot. Right. You can use a circle stencil to close off, but freehand will also do. Right. So once you are done with that, then it's just a matter of showing that this is threaded. So you just use your 45-degree set square to draw lines which are diagonal, but those lines must not go over the slot. Right, and maybe let's terminate threads here, and then you just come and finish off those diagonal lines. Right, so you can see that is how you come up with that detail. The only thing which is left is just to put the pin here and a handle for turning this nut around. So for that, it's just a matter of taking your circle stencil and placing it tangent with these holes, and you just draw that. Then all you do is draw that and that, then you can terminate that handle like that. Right, so you've got your handle in place, you've got the nut in place, and the pin. So for the pin, it's just a matter of just drawing a circle here, right, which you can just hatch to show that there's a pin there. Right, so once you have managed to draw all this detail, then the next thing which you have to do is annotations. Right, so for annotations, so this will be your 152 by 38 centers. Then you've got your 114 by 38, 114 by 38 struts. Then you've got your tie beam. So it's a 114 by 38 tie beam. Then here you've got a cross bearer, and that cross bearer is 228 by 38 cross bearer. Then here you've got 100 by 100 by 6 millimeter thick cap plate. Then this one is 48 by 3 millimeter telescopic strut. Then these are threads, and this is a slot. Then this is a nut and handle. So the nut is there, the handle is there, so I've just made it one. Then this is a 75 millimeter. It's a 75 millimeter pipe strut. Then I'd forgotten to transfer that cap plate to the bottom here, because you're also going to have a saw plate before you get a slipper. Right, so because this is out of timber, we can represent it like that, just showing those timber grains because it's in section. Alright, so that's out of timber. So what we can also do is just to transfer these dimensions for the cap plate. So you just transfer so that you can draw the saw plate. Same applies here. And just make sure that you right. So this saw plate, you have to draw it before the slipper. Right, so you can then label that. So this is going to be 100 by 100 by 6 saw plate. Then lastly, your slipper. and that sleeper is 228 by 38 sleeper. Right, sleeper. Right, so that's how you then come up with this detail, and what you then have to do is to replicate the same detail and place it here. All right, so that's what you would then need to do. You place one here and you place the other one there. So when it comes to annotations, right, first draw everything, put everything in place, then all you need to do is to then take the annotations and you just do on one. You don't necessarily have to do on all. So once you're done with that, you then put your title and scale. Right, so the title, I'm running out of space here, but let's just squeeze in the so you must always put your title and scale centrally below the drawing, but because I'm running out of space here, I'm just going to put it on the sides here. Title, all right, front view of the centering of a large semicircular arch. Then the scale, one is to 10. So that's what you'd end up with. Right, so what I want you to, I had forgotten to label that, to say that is going to be your 38 by 38 legging. So this is 38 by 38 legging. Right, so that's 38 by 38 legging. What else? I think everything else has been labeled there. So that's the final drawing. Please make sure that this is put under. So what I also suggest is that try to, if you can draw this in portrait. Right, it's much easier to manage your space so that you don't get into a situation like what you see on screen, where we've run out of space and it's becoming a bit of an issue. Right, so that brings me to the end of